Hi, let's talk about magnetic variation. Magnetic variation, also known as magnetic declination, but it's different from magnetic deviation. That's another thing. So, not deviation. So, let's begin with the Earth. The Earth is not a perfect sphere. It's an ugly potato. But for simplicity, we just assume it's a ellipsoid. So let's say here is the geographic north and here magnetic north. So what about that? We can draw some meridians for geographic and for magnetic. Yeah. Now, if we zoom in here, you see that there's an angle between the geographic meridian and the magnetic ones. And these are called magnetic variation. You know that the angle, if I draw, yeah, the angle keeps varying. And if we draw lines that the angle would be constant, those are called isogonal lines. So I'm not quite sure how to draw it like that, isogonal lines. But we focus on the angles today. Let's say the angles here is 8 degrees. What would be the magnetic variation? How do we call that? If it is 6 degrees here. So from black to blue, or from geographic north to magnetic north. So that's geographic 0 degrees here to magnetic 0 degrees magnetic. How do we convert a true heading to a magnetic heading? For example, here is 72 degrees true. What is the magnetic equivalent? If you look at how the black lines goes to the blue lines, and if you're good at math, it'll be obvious that you need to subtract 8 degrees from 72 degrees, which gives you 64 degrees magnetic. And it's the same on the other side, because here is also 8 degrees east. Because from the black line to the blue line, you go clockwise on the Earth's surface. So that is from north is going east. So the definition of variation is that it goes from true north to magnetic north, no matter from which direction you look at it. So even at the south hemisphere, or if you align the black line and the blue lines like I do here, if you go from north, or if you draw the parallel black lines here, then you go from the top of the screen to the right of the screen, which is east. So no matter which side you look at it, it is 8 degrees east. It's the east variation. So let's try another example. Let's point to that direction. 280, 2x0 true. What will be its magnetic equivalent? Same. -8 to 72 degrees magnetic. Easy. So where do we get west variation? So we need to spin the Earth. So let's get another to look at the back side of it. So true or geographic north here, and magnetic north would be on the other side as we're looking at the back. Okay. Oops. Draw some ugly lines here, and we zoom in. How do I zoom in? What does it zoom? Okay, anyway, let's draw here. From north, from true north to magnetic north, that is from the black line to the blue lines. Oh, I can zoom now. Okay, here is counterclockwise. It's to the west, from black to blue. Black here is 0 degrees true. Blue here, 0 degrees magnetic. And variation is, let's say, 12 degrees here. That's called a 12 degrees west. It's a west variation. So let's try an example. Let's say is 351 degrees true. What would be its magnetic equivalent? So if you look at it here, it's very obvious that it's not to subtract 12, but to add 12 to 351. 351 plus 12 is 003 degrees magnetic. Or if I skip that a step, it's actually 363, which obviously becomes 003 magnetic. Even if you look at this side, you should like goes from north. You need to go from north, not south. So you can draw a parallel blue lines. If you take this green point as an example, so here you look at this angle. If you look at the opposite side, you need to remember that it is not going to the east because we say from north to west. So when we say it's 12 degrees west, we mean from north to west. You can draw from south to east, but the variation is called 12 degrees west, not 12 degrees east. Okay. So another example. What would be this heading? Maybe 300, 200 degrees true, or within magnetic heading at 12. So that's 212 degrees magnetic. So if you look at that, for east variation, subtract the numbers to the true heading. For west variation, add the number to the true heading. So there's a saying, east is least, west is best. That's for converting from true heading to magnetic heading. So similarly, from magnetic to true, you add that number for east variation and minus the number for west variation. And I'm sure your math is good enough to do it both ways. Thank you.